Hello everyone, welcome back to another video. This video is going to be a introduction to derivatives, and I will be going over finding the derivative from first principles of a function, and I'll be starting the power rule as well. So let's get right into it. So first things first, what is a derivative? I'm going to give you like a super fundamental little explanation. So let's say you have a curve of anything. So this is just a random graph. The derivative of this graph at, let's say, the point -1. Let's say this max here is at -1. The derivative is the tangent to that exact point, and in other words, the slope. Because if you have a tangent to any part of the graph, that tangent is just going to be the value of that tangent is just going to be the slope of that specific point. Um, and it's important to note that at a max value like this, where the function is turning around, the derivative is always going to be 0, because this tangent right here doesn't have a slope. I mean, the slope is 0 is what I'm saying. So yeah, but that's off topic kind of. This is just introduction. So at any point, that's a tangent, that's a derivative. Well, that's technically a tangent, but we're finding the derivative, which is a function for the tangent. Okay, so let me show you what I mean. So to find the derivative from first principles, what do we have to do? So we have f of x, and then we make that with a limit from h going to 0. We do the function of x plus h minus the function over h. So that might be a little confusing, so let's just dive right into this one. So using this derivative from first principles, kind of little I don't know, formula, I guess you can call it. Let's find the derivative from first principles of this function right here. Okay, so f of x plus h. So f of x plus h of this function is just going to be x plus h squared, right? Because we're just plugging in x plus h for all our x values. Okay, and so then we did that part. So minus x squared, because it's minus, as you can see up here, it's minus just straight f of x, and f of x is x squared, divided by h, and we can't forget the limit of h approaching from 0. Okay. So now taking this a step further, we have x squared plus 2xh plus h squared, 6 squared over h. So I just simply FOILed there. We can see that this cancels, these two cancel out, because it's just x squared minus x squared. That'll equal 0. So then if we divide by h, we have equals 2x plus h. But it's important to note that we have the limit of h approaching 0. So if we plug in 0 for h, we just have the derivative of function f is 2x, because we were plugging in 0 for h. And now going back to the whole tangent thing I was talking about before, how would we find the derivative of this graph at the point x equals 5? Well, we would just simply plug in 5 for the x, so it would be 2, 5 equals 10. That's the slope of that graph of this function at the point x at the coordinate where x equals 5. That's just pretty much how derivatives work. So let's move on to the next example. And we're going to find this one also for using first principles, which is my least favorite way to find it. And first, the power rule will make everything so much easier and quicker when you learn it. Okay, so the limit of h approaching 0, we have x plus h squared plus 7x plus 7h, because we're plugging in x plus h for this, and so therefore 7 times x, 7 times h, minus then x squared plus 7x over h. Okay, so let's just FOIL everything out. So we have x squared plus 2xh plus h squared plus 7x plus 7h minus x squared minus 7x over h. And of course, this limit still applies there. I forget to write it every time, but it's still there. Okay, so these cancel out right here. These cancel out right here. And then, so if we divide by h also, that cancels, that cancels, that cancels, and that goes down by 1. So then we have the limit of h approaching 0, 2x plus h plus 7 over 0. Well, not over 0, my bad. Just that. And of course, because the limit is like that, this turns into a plus 0. And then it's just f prime of x equals 2x plus 7. That is the derivative of this function right here. Okay, so this looks really disgusting, and it's just not fun to do. So now let's move on to the power rule. The power rule is a lot more fun, in my opinion, and it's very simple. It is very simple to understand. It will not take much practice at all. Okay, so simply put, you have the function f of x equals x to the nth power, right? Let's just put a f of x equals, right? Then all you do is you take the power that the x is at and you bring it down to the front. So it's basically saying n times x, and then you make the power subtract by 1. And this would be equal to the derivative of that function, f prime of x. Let me make that more neat. F prime of x. Okay, so for example, x to the 5th power equals 5x to the 4th, because we're bringing that 5 down to the front, and then we're subtracting 5 by 1, which equals to 4. So 5x to the 4th power. Let's do some examples. Okay, so let's take a look at this example. This would be absolutely horrendous to have to do by first principles. You'll have to multiply x plus h to the 3rd power. It would not be fun. Then you have minus 9 times x plus h. It's just no fun. It'll take a little while, and it's just not easy. So this is where the power rule really shines through. So the power rule, let's do it. So we multiply 3 to the front. So we have 18x, and then we subtract 1 from 3 to the 2nd power. Okay, and so this is basically, so now we're on to the minus 9x. Minus 9x is basically saying minus 9x to the 1st power, right? Because there's always a 1st power over every x. So still, same thing technically. We're multiplying that to the front and subtracting by 1. So then we have still minus 9x to the 0. X to the 0 is just 1, so it's minus 9. And then what is this basically? And basically whenever you have a plus 4 without any x, that is just going to be 0. So there's no use in even writing it. It's 0. It's plus 0. It ends there. It ends at your final x value. Because what is that basically saying? It's 4x to the 0th power. Multiplying that by 0, we have 0x to the negative 1, which is still 0. So you will never get anything from just a constant. You need a variable. So anything that doesn't have a variable is just 0. Any constant. So if it was 4 or if it was 100, it would still be 0. Okay, so that is the derivative of that function. Let's move on. Let's do this one. This is the last problem for the day, and this is it looks a little bit tricky because you're like, whoa, how do I do this one? But it's actually a lot simpler than it looks. So, okay, so this is to the 1st power, right? Okay, so why is it in the denominator? Well, because what do we know about exponents? If an exponent is negative, it goes to the denominator, correct? So this is basically like saying, I'm just going to rewrite the function. It's basically like saying 4x to the negative 1 minus 6x to the negative 3 plus 8x to the negative 5. Okay. Now that we got that, now we can find the derivative. Okay, so now we multiply the negative 1 to the front. We have negative 4x to the negative 2 plus 18x to the negative 4 minus 40x to the negative 6. We're not done there. Final step, f prime of x equals -4 over x squared plus 18 over x to the fourth minus 40 over x to the sixth. And that is the derivative of that function. The power rule is very easy. You could use the power. I think I've used the power rule with every single derivative problem I've come across because I'm still learning calculus, but the power rule is insane. The power rules makes everything a lot easier. Sometimes you'll come across questions that'll make you do it from first principles, but as long as you know how to do it, it's really not that big of a deal. It just takes a little while longer. So thank you for watching. You have a great day, and let me know if you have any requests or questions, and I'll be happy to answer them.